So now we're going to continue with part 2 on experiments, moving on in chapter 10, the next few pages. And let's look at why we get causal claims from experiments. Let me move this a little bit here. Now, here are the 3 things we need to make a causal claim. Our variables need to be covariate. That means they need to move together. Now, in this case, we're talking about IVs and DVs. So if I have an independent variable and I change it, well, if they covary, if the DV is connected to it, then when I change the IV, the DV will also change. So if you're in the red group that you read and you got a certain number of questions, right? But I moved you, or I looked at the data for people in the green group, and I moved to red to green, the scores change, okay? So that is covariate, and they go together. If I change the IV, the DV will follow if there's a cause and effect relationship. Now, we get this also in correlations and association claims, right? As one thing changes, the other one does predictably. So, you know, this happens in both association and causal claims. Temporal precedence. Now, temporal just means time, precedence before. So in temporal precedence, whatever is the cause has to come before the effect. So you had to see the color before it impacted your performance on the test, right? So what were my other examples? You know, when I said wearing professional attire to an exam versus real casual sweatpants, you had to dress the certain way, and then you took the test and your score was something. So the mode of dress came first, right? So we have to have that for cause and effect. There has to be a cause first in time and then later the effect. Now again, sometimes in association claims, we also have that. Sometimes the variables we're looking at, one of them necessarily does come before the other. High school GPA comes before college GPA. So there are associations have that. So the last one, the third thing we need for causal claims is really the most important thing, because internal validity is what you don't get in other kinds of studies, okay? In experiments, that's where, internal validity just means I've controlled for all those other alternative possible explanations. In associations, you know, it could cause an effect between these 2 things I measured. I just measured them, but it could be some other third variable. In experiments, I'm ruling out all those other things by controlling all those variables. I'm making sure the only thing different between my groups is the IV. And if that's the only thing, and I've designed a good study and I don't have confounds, and that has to be the cause of the change I see in the dependent variables. So internal validity is the big deal. All right. Now, also I want to mention in any of these, you know, even starting with covariance, to be able to see a change, you know, as I change the IV, the DV changes, see right there, you have to have more than one group. You can't do an experiment on one group. You have to have a comparison group. Not necessarily a control group. It could just be a group that did something different, right? There's no, we think a control group says you don't get anything. Well, you know, if I want to know what red does to you, I'm comparing it to what if you read something in green or black? You know, how does that compare to the color red? There is no color group for that. So that's a minor thing. So as you saw in the quiz for IVs and DVs, there's always at least 2 groups. And then there can be more than 2, but there's at least 2 because you're comparing something. All right, so on this internal validity thing, what we're doing is ruling out for possible alternative explanations. So the big thing is we're controlling for other variables. You know, we're keeping things the same that are important to keep the same. Now, let's talk about what's one source of differences between my groups. I said, you know, I'm going to have these 2 groups, and I want them to start out the same, and then I'm going to go ahead and apply my level of the independent variable. I'm going to treat them differently and see what happens. I'll manipulate them, treat them differently with the IV, and then measure the DV. But I want them to start out the same. Now, if I have different people in my groups, though, people are different, so they bring with them loads of individual differences. Think about the pasta study from your chapter. So there might be differences in people's taste preferences that could affect how much they take. They're not big pasta eaters. There could be differences in how hungry they are, how quickly they want to, you know, eat, because maybe they have a class they're trying to get to, and I'll just take a little bit and eat it fast and go. What else? There are any number of things. If they're nervous because they're eating and somebody's kind of watching them, writing stuff down, that's weird. What else? If they're someone who's either maybe on a diet, or even if when I recruited people, I said, you have to be someone that just kind of eats normally and not on a diet. I still may be someone who's a little cautious, or, don't want to eat too much. And so that might affect how much I put on my plate. Okay, so, how long it's been since I ate last. So, I'm getting like 70 people in the study right there. I forget, you can look it up. A bunch of people come in, and they're randomly going to be assigned to, they don't know this, but be served pasta in a big bowl or a medium bowl. But there are all these other differences about them that could have an impact on how much they're going to put on their plate, right? So how do I control for that? Random assignment. That is how you control for that. So the idea is I'm flipping a coin to say which group each person's going to go in. And the idea is if I'm flipping a coin and it's not under the control of who actually, if you're group 1 or group 2, I leave that up to random chance. Then if I have enough people, if I have more than 4 or 6 people in my group, then just by chance, people that are more or less hungry, people that are, more or less fans of pasta, people that are in a hurry, people that are more or less nervous about eating in front of others, those individual differences are going to be evenly spread between my 2 groups at the get-go, just because of the chance. I mean, again, if I had 60 people and 30 of them are going to go one group and 30 the other, and I'm flipping a coin to decide who goes where, it's almost impossible. It's possible, but it's the chance that all the really hungry people would end up in the group where I'm serving you with a large bowl, and all the people who are just like, oh, I'm watching my weight, end up in the group with the medium bowl. That's that would never happen. I mean, the chances would be so small. That's kind of what our p-value is. The probability that something like that is explaining my data instead of my actual IV explaining my data, it's less than 5%. It could. But then I replicate it, and and then I feel like, I keep finding the same thing. So random assignment, the most important thing it does is it spreads all those individual differences about people evenly between my group, or in a way that I don't have a sampling bias or a selection bias. Okay? Your books talks about selection bias. So that's a really important control. And we don't get that in any kind of design like an association claim. We aren't randomly assigning people to groups and controlling for individual differences. Now, what's the best way to make sure that any individual difference that's represented here by a person might also be represented here? A within group study. This is also called repeated measures. If I'm running a study where I could use the same people in each level of my IB, that would be awesome, because they will bring all of their individual differences and their baggage and whatever weirdness they have with them, and that will be present in both groups, both levels of my IB. That's perfect. It's like we say that person serves as their own control. Let me give you another example. What if I'm interested in studying memory, and I'm going to do some kind of memory and learning thing, and I randomly split you into groups, and I have to think, well, there are individual differences. People just naturally have different memories. Some people may have had, head injuries as a kid, or they dropped them on their head when they were a baby. Some people might be on medications that affect memory. Some people are just more stressed or distracted when I'm taking data from them because they have an exam coming up, and the other person doesn't. There are all these things that could affect how somebody does on a memory task I might give them. So if possible, maybe I could take all of the people and run them through both versions of my task, and then all those individual differences are perfectly the same in both groups. That's awesome. If I can do repeated measures, I do. Because I also need half as many people. Let's say I want 30 people in my groups. And if I have to do it as a between groups design where I have different people, well, I'm going to need 60 people. But if I can run it as a within groups design, I can have 30 people and I just run them twice. Now you can see there would be some things where that wouldn't work. Like, let's say I'm interested in how gender affects how people rate a job applicant. And so what I want to do is show people the exact same job application, like the resume. Everything's exactly the same, but I'll change the name to be male or female. That's my independent variable. It's the only thing I want to be different. Well, I couldn't run that study as a repeated measures or within groups design, because as soon as you see the resume, you're like, oh, it's Bob Jones, and And they go, now rate this resume. And you're like, it's exactly the same, but it's Shirley Jones. I guess you guys must be studying gender, huh? Yeah. So, you know, they know what's going on, and that's not going to work. But if you can, if it's possible, then researchers absolutely prefer to do a within groups design. All right. I think we're going to stop this one here, and we're going to do a part 3 for experiments, and we'll finish out the chapter with that.